and welcome to this online revision session for AQA FP2. This session will be covering the June 2010 question 7, which is related to the topic of the Moivres theorem. As you can see, this question comes in two parts, where the first part in fact has two parts as well. Right. Part 1 of the A, we need to express the complex numbers 1 plus root 3i and 1 minus i in the form re to the I theta. Remember, r is the modulus and theta is the argument. And then, having done that, we're then going to use those to simplify an expression for the powers of those two numbers. And finally, in part B, we're going to use the result from parts A to solve this equation, where we're trying to find the roots of the number that we found in part A. Right. In fact, the cubic root, cube roots. Okay. Well, let's set off working on this question then. Well, part 1 of this question was writing these numbers in their modulus argument forms. So each of these numbers we need to find the modulus and the argument. So the first number, 1 plus root 3i, we know that its modulus is going to be equal to 1 squared plus root 3 squared square rooted, which is going to give us an answer of 3 plus 1, 4, root 4, 2. And then its argument, its angle theta, for this particular one, is going to be tan to the minus 1 of root 3 over 1, which we should know is pi by 3. Okay, that's 60 degrees. And so this number can be rewritten in the form 2e to the pi over 3i. Similarly for the second number, the 1 minus I, we know its modulus is going to be 1 squared plus 1 squared, because the imaginary part there is negative 1, which when square it will become positive. So that becomes 1 plus 1 is 2, so that becomes root 2 for its modulus. And again, its argument, theta, will then become tan to the minus 1. And in this case, it's negative 1 over 1, which gives us an angle of negative pi by 4. Okay, so it's below the theta equals 0 line. And so this number can be written in the form root 2 e to the minus pi by 4 I. Okay. So if you get both parts of number 1 correct here, you'll get an accuracy mark. Mark of 1 point there. Whereas with this part, you'll get 1 mark for getting root 2, and you'll get 1 mark for getting the negative pi by 4. Because that number was a little bit more tricky to work on. Now, as for part 2 of this question, we have to work out 1 plus root 3 I to the power of 8, and then 1 minus I to the power of 5. So if we write them in their modulus argument form, we're going to get 2e to the pi over 3 I to the power of 8 multiplied by root 2 e to the minus pi by 4i, and that's to the power of 5. So if we look at the modulus, we've got 2 to the power of 8 for the modulus here. From the second number, we've got root 2, which is, remember, is 2 to the power of a half to the power of 5, so that becomes 2 to the power of 5 over 2. And if we look at the angles, this one becomes e to the 8 pi over 3 I, and this one is e to the minus 5 pi over 4 I. So we've got the modulus in front and the angle, the e to the thetas at the end. So now we can simplify this first part. So we've got 2 to the power of 8 times 2 to the power of 5 over 2. So we can add those powers. Well, 8 is 16 over 2, and 5 over 2 and 16 over 2 gives us 21 over 2 for our modulus. And then for the argument, we've got to subtract the 8 pi over 3i minus the 5 pi over 4. So we need a common denominator again. So in that case, it will be over 12. So it's going to be 32 over 12 minus 15 over 12, which will give us 17 over 12, or 17 pi over 12 lots of I. Okay, so there we go, we've finished that part. Well, that was worth, again, 3 marks. So our 3 marks here will be 1 mark for getting the 2 to the power of 21 over 2. Okay, for putting this to e to the something, we'll get a method mark for being in the right form, and then again an accuracy mark for getting the correct angle of 17 pi over 12. Okay, well, let's move on to part B of this question, where we're now going to use that answer to solve this equation. So, what have we got? Well, we've got z cubed, and we can replace this now, the right hand side, with the 2 to the power of 21 over 2 e to the power of 17 pi over 12. Okay, now we've got to find z, we've got to take the cube root. Taking the cube root of 2 to the power of 21 over 2, we know we just have to divide this power by 3. Now to find the 3 possible roots, the angle part is a bit more difficult. So the thing we have to do is to remember that we can add on multiples of 2 pi to this part of the expression, and we still would have exactly the same point here. So here we can put 2 pi k in here, And remember, every time you rotate round 2 pi, you're back to exactly the same point on the Argand diagram as you would have had before. So, when we now divide by 3, the different values of k will calculate or will generate the 3 roots that we require. So z will become 2 to the power of 7 over 2, and then when we divide these by 3, we're going to get 17 pi over 36 plus 2 pi k over 3. Lots of I. Now, if we look carefully at what we were being told here about the form of the answer, we wanted some number a times root 2 e to the I theta, and the angle of theta is to be between negative pi and pi. So depending upon what value of k we put in, we will either get a value in that range or outside of it, as the case may be. So, if we put k as 0, that would be an obvious answer, which will lie in the range, because when k is 0, z would be equal to, well, the 2 to the power of 7 over 2, if we think about that, is the same as 2 to the power of 6 over 2 times 2 to the power of a half. And 2 to the power of 6 over 2 is the same as 2 to the 3, so that's 8. And then the 2 to the half is the root 2. This is the a root 2 bit that we require, and they'll all be the same as that. And then when k is 0, we're going to get e to the 17 pi over 36. So that's my first solution. Well, to get a value of theta which is less than 0, that's negative, one would guess that one would take k as being negative 1. And if we do that, we're going to end up with z equals 8 root 2. And now I've got to take 2 pi over 3 away from 17 pi over 36. So that would mean multiplying 2 over 3 by 12, top and bottom, which would give us 24 over 36. So 17 minus 24 gives us negative 7 pi over 36. And then the last value, well, it could be k as negative 2, but knowing that 2 pi over 3 is the same as 24 pi over 36, that's going to take me to a value which is too far in a clockwise direction. So the other solution must be when k is positive 1. And if we work that value out, z is going to be equal to, again, the 8 root 2, as before. And then it's going to become e to the power of, well, it was 17 pi over 36 minus 24 over 36 before. So now this is 17 pi over 36 plus 24 pi over 36. So 17 plus 24. Actually, it's not going to work, is it, having just said that, because that is going to give us 40. 17 plus 24 is 41 over 36 pi. I. What's the I? Yeah, should have had an I on the end of each of those, shouldn't I? Yeah. apologies, but 41 over 36 of course is bigger than 1, so that one isn't in the right range. So in fact the other solution that we require is going to be when k is -2. The answer is there. Don't prejudge yourself, jump to conclusions, be careful to check you get the right set of values. So this is going to become 8√2, and so we're subtracting 4 pi over 3, which when you multiply by 12 is 48 over 36. So 17 minus 48 is minus 31 over 36. And of course 31 over 36 is less than 1, so we're in the right range there. Okay, so this one here doesn't work. Okay, so you've got to be careful there to check you're putting in the correct values of k to give you the values that you require between -pi and pi in here. Well, it's 4 marks for solving this part. Your method mark here is a key one, realizing how you're going to generate all the possible routes that you require. We're getting the 8√2 here. You'll get a mark. Then for generating these answers, you will get your 3 marks. Okay, and you will only be deducted 1 mark if you give an answer which is outside the possible range. Okay, so these are accuracy marks in here which you require, so it'll be an accuracy mark of 2 marks for getting the 3 solutions, and if you give one that isn't in the right range then you would lose a mark. So make certain you put a cross, if you've worked one out that's wrong, make certain you've crossed it out and put a cross next to it, and maybe even worth your time underlining the 3 values and the solutions that you're actually stating in the answer. Okay, hopefully that solution was helpful. For further support for your revision, please go to the Further Maths Support Programme website.